Yes, am I audible, Hudeja?
Yes, ma'am.
So in the last class, we had started with this distance and displacement, and we had discussed the basics of what is meant by frame of reference, what is meant by rest, and what is meant by motion. And we also discussed motion in 1D, motion in 2D, motion in 3D. So we'll start with motion in 1D. And as I've told you in the last class also, that as soon as the portion of calculus will come, I'll discuss differentiation and integration in between that.
Okay.
Now, what is meant by distance? See, the first topic in your syllabus is distance. Distance basically means the total path that is covered. For example, a body starts, let's say, its journey from this point, A point. Then the body goes to B point. Then from B goes to C point. And then from C goes to D point. Let's say this is 5 meters, this is 10 meters, this is 5 meters. So when we say distance, distance means total path that has been covered. Entire, if the person has even stepped back, that will also be counted. Fine, that is what is meant by distance, total path that has been covered. So for example, here, if I want to find out what is the distance, so that will become 5 plus 10 plus 5. So that will become 20 meters. This is how we take the entire path that has been covered. No, this, and this. The entire path that has been covered. This is what is meant by distance. Now, SI unit, as I've told you, SI unit, though we study this separately, but SI unit here also we'll discuss it. So SI unit of distance, this is meters, and CGS unit is centimeters. Now, one basic conversion you should know, 1 meter is equal to 100 centimeter. This you already must be remembering. So this is what is meant by distance. If the person even turns back, no, and goes to point C, then this again 5 meter would be added. This is how we calculate distance. For distance, we take the entire path. All right. See, distance of a moving body always increases with time. This means you have distance and you have time. These are two quantities. So suppose with time, certain distance has been covered by the body. Now, even if the body is stepping back, if a person is coming back home, person has covered the entire steps and has reached his or her destination, then person is coming back. But see, even though distance, what will happen? Time will keep on increasing. Time will never stop. Even if the person steps back, time won't stop, right? So distance will always keep on getting added. It's a different quantity that we study, which is known as displacement, that we'll see later. But see, otherwise you have for displacement, we have these things where we subtract and all. But for distance, particularly for distance, we keep on adding it, because distance will always get added. Even if the person steps back, that much distance will get added. Then again, if the person steps back, that much distance will add it. It will not get subtracted, right? So for these only, we have distance always increases with time. Suppose if I draw the graph between distance and time, this will be a straight line graph. How can you interpret this graph? See, let's say for an initial time, certain distance is covered, right? This is time T1, distance that is covered is S1. Now see, I have taken another time T2. You can notice now distance is always increasing only. Even if I take a third time, that is T3, this will also increase with time. This is S3. One more thing you should remember, that this is a scalar quantity. Now scalar quantities are what? Scalar quantities are those that just have the magnitude. They do not have any direction. See, till now, did we consider any direction? No, we just added it randomly, right? So no direction is considered in scalar quantity. So distance is a scalar quantity. So if distance is a scalar quantity, its representation, how do we represent distance? We use the symbol S, that's it. S is standing for displacement. If I put an arrow over its head, that would represent a vector quantity. But right now we're just talking about the scalar quantity. So this is enough. Khudeja, just tell me, in the last class, till here you had written, no? All the three coordinates change?
Yes, ma'am. Yes, ma'am.
All right. So please start writing from here. Distance. All right.
Done, ma'am. Done, ma'am.
All right. So see, yes, Abdul Hamid has also joined. Abdul, I think you have sent your portions, no, for your half yearly exams.
Yes, ma'am.
So what are the lessons that are coming?
Ma'am, they didn't give the portions yet for the
Till
semester.
now, no portion has been assigned. The syllabus
ma'am.
is not given.
No, ma'am. No, ma'am.
Khudeja, any update about your syllabus for half yearlies?
No, ma'am.
All right. Fine, then whenever you people get your portions, no, in the next class, just update me, or else just text me on WhatsApp. Let me know. All right, with the date and the syllabus that you have, so that accordingly in the class, no, we'll cover our syllabus, and if needed, we'll take extra classes. All right. So
Okay,
yes,
ma'am.
Abdul, you had joined late today. 15.
Yes, ma'am. I didn't. I actually didn't check the message.
All right. So we had not discussed so many things. We had just discussed the meaning of distance. So towards the end of the class, you can take the screenshots of this Till here you had attended the class. So distance is basically total path that is covered. It's a scalar quantity. SI unit is meters, and you can keep on adding distance. Now, what is meant by this graph? This graph basically says that distance will always keep on increasing with time. Even if the person is stepping back, the person is going forward, time is increasing. When the person is stepping back, that time also distance will get added only, and time will keep on increasing. So it won't ever happen that you will get a negative distance. Distance will always be positive. Whether the person moves in a circle, moves in a square, moves in a straight line, moves in any direction, it will always keep on getting added. The number of steps will get added, number of the exact distance will keep on getting added. Now see, opposite to that, you have displacement. Why opposite? Because displacement is a vector quantity. Now, as soon as you have vectors, I have told you, I think in the previous class also, vectors are basically those quantities that have the magnitude, means they have the number, they'll have a direction also. And because of this direction, no, we cannot just add displacements. If you are having a quantity, we are calculating displacement. Displacement is not equal to distance. Please keep in mind. That's why we are studying this under two different headings. Displacement and distance, these are two different quantities. Now, look, regarding displacement. Earlier, I had given you an example. A person moves from A point to B point, from B to C, and from C to D. What was distance? This entire path covered was the distance. That is what we know as distance. Whatever is the entire path that has been covered, we calculate it as distance. Displacement means the shortest path that has been covered. This is what is meant by distance. So what you do, you have some initial point. Let's say the person has started from here. This is the initial point. This is the final point. How would you get the shortest path? Displacement is what? Displacement is shortest path traveled. This is written below also. You can later copy it down. Firstly, do not write down anything in here right now. I'll give you sufficient time. You can take down which amount of time you require to write it down, but right now just listen to it carefully. So this is the initial point, this is the final point. Now, how will you calculate the shortest distance that is available? So for calculation of shortest distance, best method is join the initial and final segments. In any question, in any numerical also, you will get this. This will help you. Initial and final, just join them. Initial with the final. So the displacement is this. Let's say this is 5 meters. So entire must be 20 meters, some 50 meters, something like in the previous example, we had taken this as 20 meters. You can see displacement is very less. So either displacement can be equal to distance or it has to be less because it's the shortest path. If the person steps back, we will subtract, we will not add, unlike distance. In distance, we were adding. Right? Even though the object, even though the person was stepping back, moving forward, bending, just even covering a certain distance, no, we were adding it. But in displacement, we do not consider it like that. We can use proper vectors. Right now in today's class, we'll not be needing any vectors, we'll not be needing any calculus, but in the next class, I'll tell you calculus in between. Wherever differentiation, integration, by next class, we'll do it. You have your class on Thursday now. So SI unit will remain same, meters, CGS unit is centimeters. So now, did you understand the difference? See, this entire was distance, but when we talk about the shortest initial and final path, that becomes your displacement. This is what is meant by displacement. Suppose a body starts from this point A and the body stops at this point B. Let's say separation between AB, this is 10 meters. Let's say the separation between AB is 10 meters. So initial point is this, final point is this. Now, what is the distance that is covered? Khudeja, can you tell me? The person has started from this point A, stopped at B point. What is the distance that is covered?
10 meters.
10 meters, very good. Abdul, can you tell me what is the displacement that is covered?
10 meters.
10 meters. Perfect. So this is a case where you can say displacement and distance both are equal. Why? Because it's a motion in a straight line, right? It's a motion in a straight line. The initial and final points are exactly the same. So this is an example which you can mention. A question comes in your school exams. In the short answer questions you have now in the section A, this type of question comes that when is distance equal to displacement? So you can answer this motion in a straight line, because at that time your initial and final point becomes same. So you have distance equal to displacement. Otherwise, take any example. So this is an example, 120 meters when a straight line distance is equal to displacement. All right, no need to write this one. So this is how we calculate. Now, basic question, one question is there that repeatedly comes in your half-yearly exams. Sometimes in unit tests also it is mentioned. That circular question, I'll discuss it. First, note it down from here. Note it down from here, then I'll discuss it. I'll scroll it, first note it down. And up till towards the end of the class, you can take the screenshots of that distance, a very small portion. Fine.
Okay.
Please note down this question, class, then I'll discuss it one by one. Radius of the circle is R, capital R. Just mention it. I have not mentioned it. Just mention in the bracket the radius of the circle is capital R. Note it down. I'll discuss.
Done, ma'am.
See, let me discuss the solution with you, at least for the first three parts. E point is not mentioned. Fourth, we can leave. Firstly, let us discuss the first part, A to B. So we have to find out distance also. We have to find out displacement also. And I've already told you that the radius of this circle is R. Now see class, if the body has started from A point and the body has stopped till B point. Now first distance. Look, if the body is going from here, then what did I tell you? In distance, we take the entire path that has been covered. So can anyone of you tell me what should be this distance if radius is R?
I'm R, right? Maybe.
Abdul is answering.
Yes, ma'am.
What should be the distance according to you? This part of a circle. Apply your mathematics. See, if the entire circle is 2 pi r, what should be this part?
1 by 2 pi.
This is just 3 by, this is just 1/4 of a circle, no?
Yeah.
Entire periphery of a circle is 2 pi r. So what should be this distance only? This distance would be 2 pi r divided by 4. Do you get this? Entire is 2 pi r.
Yes,
I'm
ma'am.
just taking 1/4 portion of it. So the entire distance becomes 2 pi r divided by 4. So that becomes pi r by 2. This is the distance. Now talking about the displacement. So what did I tell you? You have the initial point, you have the final point. In displacement, what do? We straight away join the initial with the final point. Now see, if this is r, this is r, this is making angle 90° over here, we can apply Pythagoras theorem to find out this, because now this is of no more use to us because distance we have already completed. In displacement, we have to just join the initial and final segments. So what we'll do? We'll apply Pythagoras theorem. So see, the side which we are finding displacement. Yes, one more thing I forgot to mention, which I had mentioned in distance. Distance, no, we represent it through just S. Displacement, this is represented through S with a arrow on its top, with an arrow on its top. Why? To just represent that this is a vector quantity. So displacements square will be equal to r square plus r square, which is 2r square. So displacement would be equal to r root 2. This is the displacement. So we have both distance and displacement for the first part. Now coming to the second part. Second part says from A to C. It means this was already here. This from A point, it covered B, then from B, it covered this and back to C point. This path is now covered in the second part from A to C. Abdul, now can you answer the distance? This. Yes, Abdul Hamid. Hudeja, can you try?
2 pi r.
See, 2 pi r is for the entire circle. So half of it would become
Pi r.
pi r. See, this is a semicircle now. This is a semicircle now. So for a semicircle, what do you have? For a semicircle, you already know that semicircle's periphery is pi r. 2 pi r divided by 2. When we just had that 1/4 portion. Just 1/4. So we took 2 pi r by 4. Now we are having half of portion. So 2 pi r divided by 2. So this becomes, distance will become 2 pi r divided by 2. 2 will get cancelled. Distance will come out to be pi r. Coming to displacement. Abdul, is the first part clear? Why distance is pi r?
Yes, ma'am.
Okay. Abdul, now at least try the displacement. See, initial point is A. Final point is C. What is this distance?
That will be
How much?
total is 2 pi r, right?
Total
is 2 pi r.
periphery is 2 pi r. Periphery.
Yeah.
I'm just saying this
take
is
half.
A point.
Pi.
This is C point. How do we calculate displacement? We join initial and final. Look
Yes,
in the
ma'am.
figure, something is given. This is radius. This is radius. So total will become
2r.
2r. Right. This is r.
Yes, ma'am.
This is r. So r plus r, that is the displacement. Why didn't we take pi r this time? Why didn't we take 2 pi? 2 pi r is the entire distance. When we talk
Yes,
about displacement, we just join the initial and final. Yes.
Yes.
So this becomes r plus r, which is 2r. Third part is also very easy. Fourth part, E, I'll mark in this question. Right now it has not been marked, no. A to A. Body has started from A point and has reached back to A point. Abdul, now this you should answer. What is the distance?
The distance from what to what? A to A, right?
A to A, yes.
Yeah. The distance from A to A, 2 pi r.
2 pi r. Very good. This is because entire circle is now covered.
Okay.
So distance would become 2
2 pi
pi r. Distance would become 2 pi r. Khudeja, can you try the displacement for this A to A point?
2 pi r.
This. See, what is the initial point?
R.
A.
What is the final point?
A.
A. So what is the difference? Is there any separation between A and A? No, not R. Look, that's what I'm telling. See, class, what is the initial point? A. What is the final point? A. What is the separation between A point and A point? Is there any separation?
No.
No.
No, both are the same point. It means no displacement has occurred because there is no difference between the initial and final point. So whenever, always remember, when you have the same distance, means the same initial and final point, and in those cases, no, blindly write your answer as 0 displacement. Distance would be something. Distance would be something. Distance can be 0. Distance can be 0 also, a positive number also, but displacement, it has to be 0 in that case because your initial and final point both are same. So displacement would become 0. Let me discuss the fourth part. C. Fourth part, A to E. Let me mark E for you. This point is E point. And the angle here that is made is pi by 6. The angle that is made here is pi by 6. Now pay attention. This is the tricky part. The first 3 parts were trivial. You were able to answer in one go, right? E part, this is a random point given. We don't even know which part is this. In the first part, we had 1/4 of a circle. So we wrote 2 pi r by 4. In the second part, we had half of a circle. So we wrote 2 pi r by 2. Do we know anything regarding this E point? We have no clue. It's just a random point that has been given, but with just one hint, that is pi by 6. Pi by 6, at least we know that the angle is mentioned to us, right? Let me draw this part from A to E separately for you, because in the diagram it becomes a little haphazard. This is your A point. This is your E point. This is pi by 6. Now class, what will be distance? Distance will, in any ways, whichever question is given to you, distance will become this only. This part is the distance covered. No, the arc that has been followed from A point to E point, right? That is the distance starting from A point to E point. That is your distance. So how will you calculate this? 2 pi r divided by what? 1, 2, 3, 4, 5, 6. You have no idea. Because this is pi by 6. This is pi by 6. This is the angle. This is not the side. So we have one relation. What am I trying to say is that this is the distance, right, from A to E. And we cannot calculate it just dividing 2 pi r by something the way we did earlier. So for displacement, we have one relation. This you must have studied in your class 10th or 9th. This is present in your either 9th or 10th. Theta is equal to length of arc divided by the radius of arc. L is what? L is length of arc. This is the relation. And R is what? R is the radius. This is a relation which is established between the length of the arc, the radius. What is the radius? This is the radius, right? And the angle. So what do we need? We need this length of arc. This is L. This is the radius and this is theta. So length will be theta into r. So length becomes theta is pi by 6 multiplied by r. That's it. You have your distance with you, right? This is your answer. This is our distance. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now, something different is in the displacement. This is also a basic formula. This will be used throughout. You will see, especially in your rotation motion, you have this relation theta is equal to L by R, uniform circular motion. We have this relation. So do not worry about this relation. This will be used. So try to remember it. And one more thing, class. One thing that has been covered in the class, please revise home, go home and revise it. After the classes, no, you have your class after class assessment that I'll tell you later on. After your class assessment, please revise whatever has been discussed in the class, because I will call any of your name and I'll ask you the thing that has been taught previously. So it's better if you revise so that you can go up with the class, because you already know this batch has started late itself, right? If you have started late, we have lots and lots of syllabus to cover. There is a lot of syllabi that is left. We have laws of motion, motion in a plane. We'll have extra classes also. You will be able to cover everything before your exams, but you have to work harder, right? So just revise
Yes,
home once, that's fine. Now coming to displacement. Displacement, I have always told you, initial and final point. Now you need this. In the earlier case, this was 90 degree. So we could use Pythagoras theorem. See, in this question, in this part, we had used Pythagoras theorem. But is it possible with the angle pi by 6? Pi by 6 means what? Pi is 180 degree. 6, so 180 degree divided by 6, that is 30 degree. This angle is given to us. This is 30 degree. Will we able to solve? So no need to solve it. This type of question rarely comes in the exam if the paper becomes very difficult. So that's why we are just having a look at this question, just in case if this question comes, you people are at least able to handle it. There is one formula which is known as sines formula. In sines formula, you have 3 angles are given, 3 sides are there. So sine of A divided by the opposite side divided by BC is equal to sine of B divided by opposite side. So opposite side is AC. Sine of C divided by the opposite side AB. This is a relation. And what are A, B, and C? They are all angles. They are all angles. Fine, this is just a note. This is just a formula. If in case, just in case this comes in your school exam, do not leave this, attempt it. How will you attempt this question? See, the triangle is made. This angle, this angle, this angle. This was A point, this is E point, this is the center of the circle O, right? This side, you know, this is R, this side, you know, this is R. What is this angle? What is this angle? What is this? This is given as 30 degree. If 2 sides are same, this is an isosceles triangle. And it means they both angle are same. So what is the sum of a triangle? The angles of a triangle, 180 degree. So x plus 30 degree is equal to 180 degree. 2x is equal to 180 minus 30 is 150. So x is 75 degree each. Now what do you know? You know this angle is 75, this angle is 75, this angle is 30. So in this formula, can you substitute? Sine A, sine B, sine C. 3 are clear? Sine A, sine B, sine C. Right? How they are clear? Because all the 3 angles are now present with you. Now regarding the opposite side, side opposite to angle A is R, you will be able to put in here. Side opposite to angle E is also R, you will be able to put in here. Just this one quantity is missing in your formula, this, which is the displacement which you are finding. All the 3 angles are given, 30 degree, 75 degree, 75 degree. This is R, this is R, just this is unknown, which you have to find. Just in case I'm not solving this further, you should just know the method. If a question comes, you should solve in this way. Clear till here?
Yes, ma'am.
Yes, ma'am.
Do one thing, note it down from here. If you have left with this figure, just complete it, note down the solution. Wherever you get stuck, ask me in between. Unmute yourself or ask, or you can write in the chat column. Best way. All right, start noting it down. And anything, if you're not able to understand, ask and get it clarified.
Ma'am, can you scroll
Written till here? Still writing?
Yes, ma'am.
Okay, note it down. Let me know. Just text me in the chat column. One more question we'll discuss. Please note down this question as well. All the dimensions are given. Then I'll discuss this. All right. Now see, this question says what? It says that a body travels from O to A in XY plane, then from B to C along Y axis. You have to find out distance, you have to find out displacement. See, first the body moves like this, XY plane mein, then it comes forward parallel to Z axis like this. So this radius is A, so we can calculate this distance. We have done the perimeter of a semicircle right now only. Then it moves 2A, then it goes 3A. So when we are calculating the distance, in distance, what do we do? In the first part, that is the distance C, OA. Let's break it down into parts and calculate. What is this OA? If radius is small a, then what would be the perimeter? Now can you answer? You have written this in your solution for the above question. Perimeter of a semicircle. Half of perimeter of a circle. Yes, Abdul. What is the perimeter of a circle?
2 pi.
Yes, Abdul.
Pi r square.
2 pi r. Pi r square is the area. 2 pi r. No, we have been discussing throughout. So if 2 pi r is for a complete circle, this is just half of a circle. Half of a circle should be now. Yes, Abdul. Yes, Khudeja. Yes, complete.
Pi r.
Pi r. Very good. See, pi r, we have discussed this above. It means you have not written that question properly, or you have just noted it down. Pi a it would become. Entire is 2 pi r. So if you're taking half of it, that becomes 2 pi r by 2. That is pi r. All right. AB is already given in the question 2a, and BC is already given in the question 3a. So how do we calculate the total distance? That becomes pi a plus 2a plus 3a. So that becomes pi a plus 5a. So this becomes a pi plus 5 meters. This is the total distance. This is how you have to calculate. Secondly, regarding displacement. See class, we have not studied vectors right now. Till now, we have not studied vectors. But one thing, just to make it as a note point, this we'll discuss in detail. Cartesian system you have. If anything is situated along x-axis, we write I cap. If anything is situated along y cap, we write j cap. If anything is situated along z-axis, we write k cap. This we'll study in detail. You have polar form, Cartesian form, there we'll study in detail. So if you are adding displacement, why? Because these are now giving the direction. Now from from here, O to A, from O to A, if this was the distance, displacement will be just this, that is A plus A, right? See, this was the distance that was covered by it. This was the distance. When we're talking about displacement, displacement is just this initial and final point. So what is OA? OA is this A plus this A, that is 2A. Now along which axis? X-axis. So what we'll write, which is the unit vector we will put? I cap. Do not worry about this part. You can leave this part also if you are not able to understand this well, because once we'll do vectors, then you will be able to relate it. But it's okay. We can at least discuss it so that time you will be able to relate it to a I cap. Now AB is given. AB is given also as 2A. So that becomes 2A J cap. And BC is given as 3A. That is BC is located along, no wait, 2A is located along Z axis. So that becomes K cap. So this becomes K cap. And C, BC, that is 3A. This is located along Y axis. So which unit vector I have told you for Y axis? J cap. Now total displacement, that becomes 2a I cap plus 2a k cap plus 3a j cap. Now how to solve this further? This we'll study in vectors only. Right now it's not possible for me to tell you everything regarding vectors, because then that will be that it itself is a very huge topic that we'll discuss it. Even if you have not understood this part also, no, that is also fine, but till here you should be able to understand till this answer, a plus 5 plus 5. Note down the solution. Anything you have not understood, please let me know. That completes with distance and displacement. Now on Thursday in the next class, I'll start with velocity and speed. Class completed?
Yes, ma'am.
All right. Now see, just please log into your Learnivio app. Learnivio portal you have, no? There log in